Hi, good morning and good afternoon. My name is Taji Joseph. Welcome to the webinar on Advanced Assembly Designs with Creo. So let us have a look at today's agenda. We will discuss about the issues that normally involved in creating and handling of large assemblies. And then we will look at some of the powerful and unique tool in Creo to help the engineers to create well-structured, well-planned, and robust assemblies. So let us start. So let us start the discussion with the challenges managing the large assemblies. First thing I would like to point out here is concurrent design. When a large group of designers work together as a team, we don't want two people doing the same thing and stopping each other's work. Instead, we need a very seamless team workflow. Secondly, some of the team members will be outside of your company. And as you know, maybe suppliers, contractors, and so forth, they need the information to match with what you are doing. But at the same time, you don't want to share all the information like your IP. You want to secure it, but at the same time, give them the information they need. There are other considerations like the ability to define design logic and rules to support the rapid creation of custom product variants of your assembly, so that you can easily get the product into your market as a variant of your existing product. Next one is tools and methodology available for the designers itself. Especially in some mid-range CAD systems, there are very limited tools in managing large assemblies. In the beginning, they may be able to put the assemblies together as easy, but as your project grow, the whole project will get slowed down and become a gridlock in the end, or at least it affect the assembly performance. Creo have a very nice, very powerful, very unique tool to address these issues. The very first thing in this list is top-down design approach. Creo offer a 6-stage top-down design process for the assembly design. So in the beginning, designers can use the conceptual tools like Creo layout to lay out the design and make the space allocation and capture the design intent. At the second stage, we create the initial structure, which is the foundation of the design, so that we can plan the design ahead, which is very critical. In this process, even the only empty part required, there should not need any geometries in it. And the benefit here is that can be managed immediately in the PDM systems like Winchell. At the third stage is capture the design intent. Creo uses its unique tool like a skeleton model, which we'll talk and discuss in more details in a couple of minutes. The fourth stage is managing the interdependencies relationship between various various design objects. We can take the full advantage of Creo's parametric and associative functions to properly and efficiently communicate the design intent downwards. Fifth stage is, of course, the communication of that information. The top-down designer can distribute the design task and the geometrical functions to the individual group or team members using publish geom and copy geometry functionalities within Creo. It will reduce the design complexity and improve the quality of the design. And in the end, once all these stages have been completed, designer can then work on the individual components and finish the design. One of the key elements of the top-down design approach is what I have explained in the third stage is skeleton modeling. Team leader can build critical geometries that actually drives the other parts and the sub-assemblies. So it's easy to plan the framework of an assembly to make seamless changes that automatically propagate to the reference components. Also, when you create a skeleton model, it will be always created as the very first component in the model tree. And the other consideration, like it won't be calculated in the bill of material or mass properties calculation. And it will be so easy to find the information at any point of time because the critical information is always stored at the skeleton level. Once you add these critical geometry information to the skeleton model, the next thing is the collaboration to share the geometry as references to build the component features. Now, published geometry and copy geometries are two main data sharing features that Creo uses quite often uses. Once the model is activated, the published features enables the designers to identify and collect a selection of references from skeleton and apply them to a feature. These references can be things like surface sets, curve chains, and references, or even datum features. Um, in addition to that, advanced assembly extension will also enable the users to use the tools like merge inheritance from one part to another part. And with the introduction of multi-body in Creo 7, we can treat them as separate bodies and utilize Boolean tools to further operations.